And I'm going to hand over now to Trevor Wright from Metalbank. So connection between our last speaker and our next one, but really looking forward to hearing what you've got to say, Trevor.
Yeah, thanks very much. Yeah, it's good to see that getting into the Triumph project. I'll share my screen. Just let me know if that's going okay.
Yep, you've got it.
I was kind of thinking of what to talk about when Rick gave us a call and said, do you want to have a chat? And so what I thought I'd do is talk about a target we call the Great Eastern Target in our Eidsvold project. And it's a target that sits undercover and has been it's been an interesting exercise in how we've got to this point. And the great thing is we've just commenced drilling it, and it's one of those targets that I think geologists spend a career thinking about, and often sort of life passes them by because they don't get enough information or enough confidence to de-risk it, and they end up just sitting there in the ground. And so I thought what I'd do is just discuss how Metalbank as a company has gone through the process to be able to get a drill rig on the ground and have a go at this thing, because I hope you can see that by the time we finish this talk, you'll see how compelling a target is from a project generation point of view. So I'll be very brief about Metalbank as a company. There's a bit of a disclaimer. But essentially, we've got two projects. We've got the 8 Mile project, which is just up the road from Mount Rawdon, and then we've got the Eidsvold project, which is kind of in the middle of some of the bigger deposits in the district. We've just finished drilling at the 8 Mile project, and the assays are in the lab at the moment. And so I thought I'll have a chat about the Eidsvold project. We picked this up as a private company in 2010. It was a guy, Tony Schreck, who some of you may know, and a couple of geophysicists and myself. And basically, people were dropping ground left, right, and centre, and we saw 100,000 ounce gold field, what looked like a big intrusive complex, and it was wide open. So we picked it up. Subsequently, that company got merged in with Metalbank and became a listed entity. All of the work essentially done on the project is focused on the 100,000 ounce gold field. In Newcrest in 1995, drilled 14 holes outside of the gold field in adjacent or along strike from the gold field and also undercover. And they found Gosowong in Indonesia and essentially got told they had to pack up and move on out. So the place hasn't been tested at all, and it's a good start when most of it's actually sitting undercover, and the bit that's sticking out has 100,000 ounces in it. The type of deposits we're looking for, we're kind of moving down towards the pluton here, and we're looking for either spines or breccias coming off that pluton with a sort of a Mount Leyshon Kidston type analogy. So this is the Great Eastern Target. This is an early image of it for what you can see here. There's what looks like a deep magnetic low, a bit of a magnetic ring around it. And this image on the right here, you can see is all yellow and it's cover sediment. So we knew about this very early on in the piece that's really interesting. And then we hightailed back to the gold field and up this western flank because the stuff was sticking out of the ground. And there it stayed with us waxing lyrical and arm waving about how good it could be for quite a few years. We had a very good assessment of the Eidsvold goldfield, which you can see here. We did a fair bit of surface work, did a bit of geophysics, and did the old, we'll just go deeper from what the old guys did. Unfortunately, deeper here means going straight into the Eidsvold township. And when we had a really good look and modelled up the loads and the thicknesses of them, it didn't look like it was going to stack up from an economic point of view for us. So we then started looking along strike, and we saw this thing up here called Mount Brady, and there was one reference to it, and it was a 122 gram sample that had been determined to be contaminated. So we thought we'd go up there and have a look, and it looked like there was a fertile breccia system going on in there, and we did a fair bit of work up there as well. The highlight of the program was that we got a metre at 17.5 grams copper and 2.5% copper and a sort of tuff-site spine coming up and through there. In the meantime, this target sitting here is still parked up, and we still have no idea really what to do. So it got to the point where we sat down one night over some beers, and we were thinking about it, and we decided amongst ourselves that we can either stare at it or do something about it. And because it was the big elephant in the room for us. And the mag data we had is 400 metre spaced government open file data. We discussed whether we wanted to fly a new survey. Because we're under a fair bit of cover, we didn't think that tightening up on the survey spacing was going to help at all. And as a junior, we can't just go in and start drilling it willy-nilly, because we just don't have the resources of some of the bigger companies. And like's been alluded to before, the shareholders get a bit impatient if you keep hitting dusters in the same place. So we decided to start at the beginning again. And you know, there's a great saying from Donald Rumsfeld when that war in Iraq was going on, when they couldn't find these WMDs, and it's essentially the same as what we were dealing with. There's a whole bunch of stuff we know, and there's a whole bunch of stuff we don't know, and there's a whole bunch of stuff we don't know that we don't know. So we thought we'd break it down into 4 questions. And you know, what do we know about the Eidsvold Intrusive Complex? What do we know about the cover sediment? Can we see through it with anything? What exploration tools do we know work, and what exploration tools do we need to kind of see if they would work? And so we started on the journey. It turns out we actually know quite a bit about the Eidsvold Intrusive Complex, and a lot of that was helped out by a guy called Greg Morrison, which I know is listening here today, and a few of you know about his efforts in the intrusion-related space. And we got him in quite early on to help out with us, to figure out, you know, what it is we're dealing with. There's the literature on the Eidsvold Goldfield has been exceptionally confusing. It's been named every type of deposit under the sun, and we decided to take a very simple approach to it quite early on, and that is, can we see some form of metallogenic association that would support an IRG relationship? And it turns out we can. So we ticked the first box. Yep, we're pretty confident that this is an IRG system parked up in this pluton. Another thing we learned very quickly, and this is something that Greg helped us with as well, is that it's a really fertile intrusive complex. It's got a whole bunch of textures in the rocks that we can see when we're mapping that tell us that we're in the right neighbourhood. We can see rocks that are essentially completely buggered. We can see stuff that looks like it's in the roof zone, so it's been over pressured here. We've got shatter breccia, which you often get on the margins, and we see this tuff-site spine, which is this sort of breccia here with rock flour, and this is where we intersected the 1 metre at 17.5 grams gold. We also see very good evidence for zoning. We've got this granodiorites, we see monzonites, we've got granites, we've got some rhyolites, we've got some aplites running through this thing, and we see some compositional changes, so stuff that would suggest that we're real close to the engine room of this thing. We were seeing the K-feldspar and quartz infilling and replacing the alteration. We're also seeing the development of morolitic cavities that are starting to link up together, and we're also seeing where the rocks are recrystallizing into these micropegmatites. All the sort of stuff that we would expect to see, or good places that we see if you're getting trapped fluids in a hydrothermal system. So we can tell that the inference is that the intrusive complex is bloody fertile, and it's a matter of finding more of these things. So you can see on the top here, this is where the Mount Brady system sticks out of the ground in a rare sort of window of exposure within this complex. We went and did some drilling and got some petrology done, and we can see clear evidence for 3 stages of the system. We see the early comagmatic stage, which is essentially the emplacement of the pluton. We then see a sinogranite intrusion coming in, which is essentially the causative intrusion, early hot moly copper mineralization, and it looks like there's a hydrothermal fluid stage coming in over the top or later as the system's cooling. The inference being the main ore forming stage, where we start seeing some of the more cooler fluids that are promoting arsenic, gold, silver, copper, zinc, some of the stuff we expect on the sides of these systems. Some of the work that, if any of you do have intrusion related projects, I suggest you go and talk to Greg, or go and have a look at some of the fantastic work him and Phil Blevin did in the 1990s on the P425 Amora project. And they went and classified a whole bunch of these systems in Queensland. And when Greg had a look at our stuff, he said, guys, I think you're dealing with a moly tungsten bismuth system. We should be on the periphery. And according to his classification, we're sitting somewhere in about the Kidston zone. So we're seeing a sinogranite moly tungsten core, and we would expect to see gold mineralization sitting either above or on the side of that main core zone. So what do we know about the sediment cover? Well, there's a guy who's a geologist that we know, Mike Whitty. He's got a siltstone mine there, and he mines it because it's exceptionally clean. There's a sandy silt, sometimes a bit of gravel, and it's unconformably overlain by a weathered granite contact. And we know it's a weathered granite contact because we can barely make it out up at Mount Brady when we see it. So we can see that with that we should be able to see any dispersion of elements or anything. This would be an ideal host for of getting that stuff through. We don't have any idea at this point how thick it is, so that's something that's been a work in progress if you haven't drilled any holes into it. What exploration tools do we know work here? Well, Newcrest and the work they did were able to demonstrate that where they hit zones of magnetite destruction, which we can see in some of these sort of washed out zones of magnetics. These guys hit mineralization. They hit about 10 meters of 0.2 gold with some arsenic and antimony, so distal metallogenic package there as well. So that gives us a big tick in terms of the project and being able to use that as one of our regional target defining tools. We also could go up to Mount Brady and we can see some of the stuff that we did with the magnetics and the mapping and the drill holes. We can see hornfelsing on the margins of this thing. You can see a bit here running around and to the side here. So when we often see some of these peripheral rings, we've got a fairly good level of confidence that some of them are in fact hornfelsing related to the later emplacement of these sinogranites. Also, we did a fair bit of IP work up here, and we tested a zone up under a little bit of cover with a mag low and a resistivity low, and we were able to demonstrate very strong broad sericide alteration, and we managed to clip 3 meters at 2.5 grams gold in there. And what that did is it validated the tool to expand that over the rest of the Eidsvold project. So we decided to go and run an airborne EM survey on that basis, with the view that we could then use the resistivity like we were using with the IP, and then combine that with areas of magnetic lows or washed out zones to give us a whole bunch of anomalies. And we came up with about 20 of them. And where we could model these paleo topo highs and under the basement, we got even more excited. So we got a whole bunch of geophysical targets, and things were looking pretty good. And then what we were also able to do, and this was just a serendipitous thing that happened one day when I was mucking around in Micromine, pull together the 3D mag models and EM models, put them in a whole bunch of sections and start drawing profiles along them that seem to fit. We were able to use a couple of the old drill holes that Newcrest used to say, this looks like it's going to work okay. And we came up with a really good basement model. And what it was able to do very quickly for us is say, well, actually, there's a whole bunch of areas that we're not interested in. So when we're looking undercover, we're kind of thinking anything over 100 meters or greatly over 100 meters is just a bit too much of a bite to chew for us. And we'll look at the stuff that's less than sort of 0 to 100 meters and go from there based on our modeling. So it was able to get rid of pretty much a third of the area as two hard baskets straight away, and we can focus in on some of these other areas. And then we came to the big issue of what are we going to do when it comes to the geochemistry. The guys in the team, Tony, Shrek and myself, we hadn't had much experience of exploring undercover and of using any types of geochemical tools. So we decided to go to the PACRIM conference and do this short course here. And we got talking to Dennis Arn, and they showed us all these pictures, and these guys seem to have this stuff down pat, and they can show all sorts of dispersion models and electrochemical models and all the rest of it for the type of stuff we're looking for. And they were also able to say, look, guys, you want to be looking for pH as well. So we got Dennis Arn at the end of this conference and had a chat to him and said, well, what do you think? This is our project. He said, I reckon you guys have got a good candidate and you should go for it. Give pH a go and aqua regia soils and see what happens. So we did. And we put some test lines. At this stage, we wanted to test as many of those targets as possible. So we put a whole bunch of test lines over here. We did some pH. We developed our own pH regime in the donga at the Eidsvold campground, and away we went. And lo and behold, the whole thing worked. And we got some anomalies up here at the Great Eastern target. We got some other anomalies along this magnetic low trend through here, or mainly on the margins of it, and another spot down here. So we found 3 completely new targets or quantitative targets that we hadn't been able to rationalize before. One of the things that we had to take into account is metal scavenging, and we're able to do that. We can normalize the data against that and make sure that we're not getting too caught up in the metal scavenging and dealing with a reasonable data set that adheres to what we're trying to do. The pH worked really well. We've had very distinct differences that are statistically significant, and based on that, we decided to roll it out over all of these 3 targets. But the one I'm going to focus on today is the Great Eastern target here as our prime example. Once we did all that, we decided we better just get back to basics again and come up with an exploration model, just a basic model that we can work with. And this model on the right here is a bit of a structural model, and also a paragenesis of what we've learned around the rest of the project area. We've got a series of ring structures and some elongate structures running along the margins of this intrusive complex. The main intrusion sitting here with the mother intrusion, and something different poking through it, which possibly the same cyanogranite intrusion that we're seeing up at Mount Brady. Then we decided we better go and hone in on this target a bit more and get some modelling done. So I got Mike Sexton to go and model up the mag, and he did something very unusual. He called me, and usually he's diving, and he said, mate, this looks really like Mount Leyshon. And Mike had a lot to do with Mount Leyshon in the early days. He says it's about 800 meters down. You've got very fine remnantly magnetized magnetite in there, and I think we've got a real nice alteration halo around it, and we could even model this big hornfowsing ring sitting around here. And you can see this is a 1,000 meter scale. So this isn't an insignificant anomaly that we've got here. So then we turned our attention to the resistivity that we got on the EM and decided to model that up as well. And two independent data sets now talking almost the same language. And we can see the alteration here. This doesn't model down anywhere near as deep as the mag, but it goes down to about 250 odd meters, and it sits as a halo sitting around this core of this system. That was pretty exciting. Then a few months ago, we decided to go and we got some CEI funding. We thought we better get this target sorted out really well before we start getting into it. And we decided to go and do some grid space soils over here. And we plotted it up, looked at the metallogenic associations in this thing, and we can see there's a peripheral gold zone here. We can see a low temperature zone sitting around the margins, and also what we're interpreting as a high temperature zone, moly, lead, arsenic, some tellurium and bismuth sitting in there. And then the soil analysis, the soil pH analysis marries up with that as well. We're seeing very strong soils in here. The inference for that is that we've got some sulfides that are weathering down in the basement, and it's zoning out onto the periphery. I haven't seen this sort of coherence and data sets in my career as a geologist. Usually you get one or two and you squeeze a few more in and you know, blink your eye and hope for the best, but this has been exceptionally coherent. And then before we decided to drill, we thought we better go and run some IP lines because you just never quite know what you might see. So we ran an IP line north-south right across the guts of this target, and we get nearly a one-to-one match with the soil geochemistry to EM and the magnetics. You can see in the middle here, there's a chargeability anomaly with a weak resistivity. This is exactly the sort of stuff that we're interested in and what we see up at Mount Brady, and also what we saw at the Triumph project as well in these types of systems. It looks like we've got three anomalies here, but these two here are sitting right over the main anomaly. You can see this zone through here and also through here, and that's reflecting probably the cover sequence. Just this afternoon before we started this chat, I thought, well, I'll just have a quick look to see what it actually looks like when we put the modelled core sitting underneath it with the chargeability and the IP resistivity. And the model that we're kind of running on here is that there's possibly something tapping off this remnant core, and it's really starting to look like we've got a big alteration package around the outside of it in this target zone here. This is a 500 meter spacing between these grids here to give you a sense of how big this thing could be. The other drill ready targets, we've still got Mount Brady and this thing called 40 Horse and Tower Hill, which we're still ready to have a look at. And they're all sort of talking the same language as what we're seeing in the Great Eastern target. So we're feeling fairly bullish for guys that haven't put any drill holes into any of these targets. So in summary, the target development here has been fairly systematic. We started off with a conceptual geophysical target, which, as most exploration geos, we can find stacks of them, and they just remain ideas unless you can do something more with them. In the last month or two, we've now got 5 independent data sets, all supporting a large-scale IRG system and very strong coherence. And what we've learned is that it doesn't take much to de-risk these things if you've got the right architecture. For us, it was having a granite that's got some weathering at the surface and a nice clean sediment sitting on top. We used all the data that we'd already collected from previous work. We leaned on our consultants that we use. So we've got the geochemistry guy, we've got petrologists, we've got geological guys, and they they're all very good bang for their buck because they hone in on the important stuff real fast. We decided to give the soil pH a go. It didn't actually cost anything. We'd have a cup of tea in the morning, eat our breakfast, and spend 20 minutes getting these pH samples together before sending the soils out. And it's given us a fantastic data tool. You know, it's to add to the geochemistry. We were able to calibrate quite a few of the tools which were specific to this project, and then roll them out on a bigger scale. And the key ones for us were the geophysical tools, which we could then go and apply over big swathes of the project. And the other thing that we've done is we've been fairly unemotional. The whole thing's been data driven. We don't know where it's all going to end, and you know, until we get the drill rig down into there, we don't even know if it's real or not, because that's the ultimate, you know, that's the ultimate truth tool. But the data is certainly pointing us in the right direction, and as geologists, that's our job. So we're pretty happy with where this has ended up. The stuff we still don't know is we don't actually know what the cover depth is. We've got no idea. We've modelled it, but again, we've got to put a drill rig down there. IP anomalies, well, as anyone that's dealt with a lot of them will know, there's almost as many false positives as there are, you know, hits with them. We don't know what the dispersion in this geochemistry and soil pH is. We don't know if it's going a long way, if it's going a small way, if it's just a genuine coincidence or not. So, you know, that's why we're there. The maiden drilling program's commencing this week. It's been a bit wet for our long-suffering senior geo, but the rig's on site, and I can tell you we're drilling. We're very stoked to have 2 CEI-funded holes at the Great Eastern target that is going to make up the drilling program and greatly de-risks us having this crack undercover. That's my talk.
Wow, thanks, Trevor. And we have some feedback from our manager of the CEI program, who says you're a model customer and he loves dealing with you. So very excited to see the results of that drilling, and do keep us posted. Now we've got some questions for you, so I'll read those out. At Eidsvold, do you see any USTs?
At Eidsvold, I haven't seen any at Mount Brady. I wasn't there when they did the 5 drill holes at Mount Brady in 2014, but I don't recall seeing anything in there. And I know that Greg's reviewed the core, Greg Morrison, and I don't believe he saw anything in there as well.
Excuse me. All right, that was Dave Royal, and Greg Farlow says, great presentation, Trev. So there's some feedback. I was wanting to know a little bit more about the pH in soils, because for all my years in exploration, as an exploration geologist, we never actually did that. We just did, you know, straight soil geochemistry. So I think that's a fantastic tool. And
yeah,
you know, you were saying you're not sure about the amount of dispersion. What about depth, influence of depth through cover and that kind of thing?
I think it's well, first of all, we've got to prove that it works, but yeah, it's got a nice coherence. I've got to say that I was horrendously skeptical, and especially when we went to these talks, and these guys were, you know, started off, and then they just started throwing example after example after example of what these guys had been doing, you know, that specialise in looking under, you know, using their geochemistry specialists to look undercover. And so we thought, well, we'll give it a go and see what happens. And we leaned on Dennis Arndt to give us an independent view of whether we were actually seeing pH. And one of the things he pointed out to us is, as soon as you take it from being a logarithmic scale and turn it into H+ as a linear scale, you really start seeing the statistical breaks in it. And so when we gave it a go, we thought, you know, we know where this is going to go. It's going to be a good exercise. We're going to give it a go, and then we'll be on to the next bit of head scratching to find out what else will work. But I got to say, there's no cost involved in it apart from buying a meter and a bit of deionized water, and that's it, and a couple of bottles. And for an exploration tool, it's fantastic, you know, to be able to go and it's you know, everyone can get the idea that you're getting sort of small amounts of acid mine drainage in a weathering profile. So if you can demonstrate on your project that, you know, you don't have some, you know, something that's going to suck all your geochem in, like some sort of shaly cover, and you've got the right basement and you've got the right cover sediment, I think it's worth a go.
Yeah. Well, Megan James in the Q&A has asked, she's also interested, can you describe the sample and testing method used for your pH in soils, please?
Yeah, it was kind of like, felt like we were on Breaking Bad, actually. So what we did is we set up 5 bottles and took a heap tablespoon, you know, same tablespoon, and put that in the top of each one, and then put a 1:5 ratio of that deionized water in it, and put the caps on straight away. The pH meter is exceptionally sensitive, and then we'd put it in the control, which just had the water in it and got a reading, and then we'd go and take the lid off, and, you know, after we'd shaken it up and let them all sit for a couple minutes, we'd put it into the slurry and let it calm down, and then we'd take the reading, clean it in the water, and off to the next one. And then we'd do batches of 5, and then when we finished, we'd then go and have a look at what the water was, the original water that we started, to make sure that things hadn't gone out of whack. And each reading took probably 40 seconds, I guess. And then once you start getting going, it just turns into a
routine.
Yeah.
So Megan's also followed up with, do you need a wet environment? So would
No,
this work, you know, further west?
Well, I don't think we were taking a tablespoon out of the soil sample that was going to the lab. So when we were taking our soils, they were mainly dry. And these guys that, when we went to this conference, they were talking about, you know, there's quite a bit of difference of where you take your sample in the profile. And one of the things Dennis said is, why don't you start at 20 to 30 centimeters? That seems to be the sweet spot in just about all the stuff that they do. And we started there, and we just were very careful to make sure that we tried to take it at about that depth. And from memory, all of our samples were dry.
Yeah. And she says, excellent, thanks. Richard Blewett is commenting, he suspects that the pH changes that you see will also be visible in the vegetation in satellite data. So that might be another way to see, like another data set that you could try and match up.
Yeah,